Alright, the next topic we're going to tackle is what's called the zero product property, dealing with quadratics. Okay, and we're going to do a couple of things just to kind of help you understand. Right now we have an equation right here. This expression right here is equal to 0. Alright, so one thing we're going to practice just real quick is I want to practice what's called the FOIL method. We're going to do it in 2 different ways. You don't have to do the FOIL method in order to solve this problem. This is just for your knowledge. Okay? So the first thing we're going to do is we're going to multiply these 2 binomials together. This is called a binomial. This is called a binomial. Binomial is when you're dealing with a variable and a constant. All right, the variable being x, the constant being 1. Okay, so we're going to do what's called the FOIL method, just for practice. But F-O-I-L. Okay. F, it's a not very good F, but F represents the first terms, the product of the first terms. Our first terms are this right there. Those are our first terms. So our first terms are equal to x times a 3x. And x times 3x is 3x squared. Okay? So those are our first terms. Then we have what's called our outer terms. Our outer terms are the terms that are on the furthest on the outside. So I'm going to call those my outside terms. And our outer terms are x and the number 4. So x times 4, the product is 4x. Alright, so now we're going to switch. Now we're going to go to our inside terms. Our inside terms are right there. So right inside. Alright, and our inner products are the number 1 and the variable right here we have a 3x. And 1 times 3x is 3x. And lastly, our last terms are the last terms of each binomial. 1 being the last term, 4 being the last term. So our last terms are 1 times 4, which is 4. Okay? Now, if you look right here, these terms are like terms. So we can actually add those together and get a total of 7x. So our final expression over here is 3x squared plus 7x plus 4 equals 0. Alright? Now what I want you to understand, this right here is what's known as standard form. Okay? That's standard form. This form over here, this is known as what's called factored form. Factored form. Because these 2 factors multiplied together equal this. Now, you didn't have to know all of this to solve this problem. I just want you to understand the difference between standard and factored. Now, factored form helps us do one thing and one thing only. It helps us find our zeros so fast. Because all we have to do is we have to set this equal to 0 and set this equal to 0. So we're going to set, right now, x plus 1 equals 0. And then we're also going to set 3x plus 4 equals 0. So all we got to do is find, like, what number would we plug in when we add it to a 1 to equal 0? Well, that number has to be -1. Now, if you didn't know that, you could just do your algebraic skills of take away 1 from this side and take away 1 from this side. So we have additive inverses. Those zero out. We're left with x equals -1. Now, this one's a little bit trickier, all right? But you can just do your problem-solving process. Just take away 4 from this side to get to 0. Take away 4 from this side, and you're left with 3x equals -4. And then what would you do to both sides to finally solve for this letter called x, the variable? You divide both sides by the number 3. And you get x equals -4/3. Okay? So we have x equals -1 and x equals -4/3. Now what we're going to do is we're going to go to Desmos. We're going to type this in because I want you to see that this factored form is actually the same quadratic function as this standard form. So we'll go to Desmos. We'll type in 3x squared plus 7x plus 4. And then we're going to type in parentheses x plus 1. And open up parentheses, I believe, what was it again? 3x plus 4. Okay, type in 3x plus 4. And I want you to see that these are exactly the same graph. Alright? I'm going to zoom in a little bit so we can look at our zeros. And you can kind of see right here, we have a 0 here, we have a 0 here. Now, in Desmos, they're not going to give you the fraction, okay? They're not going to give you that that's actually equal to negative 4/3, alright? But that, you can see this is what's called the smallest 0, because it's smaller than over here. We call this the largest 0. So we have the smallest 0, we have the largest 0. So when we're asking for our answers, okay, which right here says which one was the smaller, we're going to type in negative 4 divided by 3. Okay, and if it asks us for the larger 0, we're going to type in a negative 1. That's the larger of the two zeros. Okay, we're going to type those in we're going to hit check so you can see it's right. Okay, let's go back to our work real quick. One thing I want you to see is I want you to see that these are in fact the same. Okay, this is also known as the vertex or the minimum of the graph. All right, but if you needed to convert this right here to a fraction, all you got to do is type in negative 1 point. Now that 3 means it's repeating forever. All right, and see here, I'm not sure if Desmos does that. Let me see here, see if it does it for us. No, it looks like it doesn't. Okay, but if you do have a graphing calculator, all right, if you type in negative 1.3 repeating and you do it long enough, all right, hit the math button, press enter twice, and we'll change it to that fraction. Now, my suggestion is not to worry about decimals, but just do it by hand. It's a heck of a lot easier. I'll try one more time to see if it does change it. All right, negative 1 point. Let's keep going. Oh, good. Looks like I do it enough, and it will change it. Okay, so it looks like you just have to keep doing that repeating decimal enough to change that decimal to a fraction, so you can type it into your Khan Academy. All right. But my suggestion when you're doing these is just simply set your equations equal to 0. So this one we're going to do a little bit faster. Okay, so what we're going to do is we're going to set this equal to 0, and then we're going to set this equal to 0. All right, so the first thing you do is you put x minus 5 equals 0, and over here we're going to write 5x plus 2 equals 0. And what we're finding is we're finding the zeros, also known as the x-intercepts. Let's put above this that represents the x-intercepts. Okay, they're also known as solutions. That's another word that you might see, solutions, that represents the 0. And the last one, roots. These are all interchangeable for what word? All the zeros of the function. And once again, the zeros, in case you're wondering what the zeros were, the zeros are where the parabola, this is known as a parabola, where the parabola hits the x-axis. Those are known as zeros. Okay, so here we go. This one's pretty easy. You can pretty much figure out the number 5. 5 minus 5 is 0. So if you're going to solve it algebraically, you just add 5 to both sides of this equal sign. These add up to 0. We're simply left with x equals, and 0 plus 5 is 5. So we have one of our zeros is at a 5. The other 0, we would take away 2 from this side and take away 2 from this side. And you're left with 5x equals negative 2. These are additive inverses. We always make sure they add up to 0. 0 minus 2 is negative 2. Then we divide both sides by 5. And when those cancel out to a 1, we get x equals negative 2/5. And then you have to ask yourself, which one's the larger and which one's the smaller? Well, I think you can pretty much see the larger one is the number 5. The smaller one is negative 2/5. So that's what I'm going to type in. And that's how you find what's called the zeros using the zero product property. When you plug these numbers in, it makes everything equal to 0. So I'll type those in, and then that'll be Smallest zero was negative 2/5. Okay, and the larger zero was the number 5. And then we hit check, and voila. Okay. Now, if you mess up and these videos aren't helping, you can also see right here where it says see step-by-step solution, and you can go down here and see what they do. Looks like they do the exact same thing that I do. Okay. So, hope this was helpful, and have a great rest of your day.